Welcome back to our Scala class, and we will continue discussion on traits. So one of the building blocks in object-oriented applications. So again, traits are not full class blueprints, but smaller, so to say, smaller. You could say incomplete, but smaller portions. You could say, and we were looking at these examples of the dogs which have these traits. And well, there are also functions, right, with defining methods for these traits. So you may have questions, well, how about fields and how about parameters? Again, so remember, parameters are things we pass in as when initializing. And in Scala 2, which is still used in most widely in industry-wise, you don't have parameters, but you do have fields if you want, right? And the cool thing is, well, the easy thing is that actually fields, you can use the same syntax we use for defining methods. So let's take a look at this, how it is done in the book, which I want to mention you again. Where's my book? My favorite book, right, is not from here, but from the Scala cookbook by Alvin, right, which we saw in a previous video. So let's take an example. I'll go to project and I'll make a trait. I'll make a pizza trait. This is from chapter 6 of the 6.2. Of the cookbook, and I will make a new Scala class, right, and I'll make a trait, right, and I'll make something called a pizza trait, right, pizza trait, right. Again, of course, I don't have to do this. I could keep using this day 14 traits file. I mean, again, there's absolutely no requirement for this, but it's again, so I'll add, and so I will add something, maybe define max num toppings and int, and that's it. So how to understand this? So this is basically parameters method, an integer. So this is actually so if you want, so actually defining a method is the most flexible way to require some field, right? So what happens now? So basically, if you want to use this max number topping, so all it says is, you know, the name, and you get back an integer, right? So so this is the most flexible way, right? You don't put any parameters, of course, in here, right? So if I make a class, let's say a small pizza, let's do my small pizza, right? We are going to extend, of course, pizza trait, right? Of course, right? And we can use, right, of course I can't, I will have to, now the IntelliJ is going to warn me, you better implement this or it's going to be abstract. Well, I'm going to make it implement, so I'll say max number toppings, right, and it should, well, it's not helping me, but no, max num toppings and val equals, let's say 4, right, and now it's legal. So notice I used a val, right? So now I can use it, right? We'll check it afterwards. We will test it, right? So and yeah, we could have used val here as well, right? But actually this is the most flexible way, and this is the recommended way, right? So this is the way you write. So you just, of course, you need a type, right? And so this is actually a method, but when you declare it, you have quite a bit of flexibility, right? So a value, right? We can even use, right? Even do something, maybe even let's say class medium pizza. Let's make a medium pizza, right? We're gonna extend the same trait, right? Again, we'll be eating too much pizza soon, right? And we can make a var, right? Var max num toppings. Again, we'll make what's a medium pizza can have, let's say, I don't know, 7, right? We can have 7, right? So this is variable. So this is, of course, this is fixable, right? So, and let's make a class, let's say, large pizza, right? Let's make a class large pizza, right? Extends pizza trait, right? And let's see again. I'm still okay. So val var, and I can in fact make a function of code with 2, right? So max num toppings, right? And I can make it, of course it has to retrieve an integer, and now I can do some crazy calculation, right? Do some calculations, calculations to make to actually get the count of toppings, and then I can return it. Maybe I'll return, I don't know, 23, right? So, okay, so this gives us, again, so because traits are extremely abstract, right? It's an abstraction, right? You say, okay, you need this maximum toppings. How you get it, right? Well, you can make it a value, a fixed value. Maybe it's something you can change, right? A variable. And maybe you can make a maximum number of toppings. Okay, and how about, let's try again. Let's see if we can make a costume. We can. Let's do class costume pizza, right? Extends pizza trait, right? And well, thing is, I want to make it here. So number of toppings, right? And I'll make it a field, so parameter, right? Topping parameter, right? I'll make it an integer, right? So idea is this, right? This is custom pizza, right? I still have to implement this, right? The question is now, can I do it immediately? Will it overwrite? Well, that's a good question actually, right? So can I do this? Let's try this. This probably won't work, but let's try it first, right? This probably won't work. This is not allowed, but I think this was allowed. I think used to be allowed. Yeah, this is actually okay. So this, I can even do it this way instead of this. So what's the difference between these two? Well, again, this is technically a field. This is a parameter which we can use inside and afterwards, right? So that's the one way of doing it, right? So this also meets using a parameter, a val or var parameter, right? We can try var. I'll try var as well, like, so it doesn't break. No break, right? But I can do this, right? So this is not, so val, right, would work as well as parameter. Why? Okay, so why doesn't work with var without it? Why? Remember when we worked with classes, when you have used val and val, you have these custom getters, right? The value. So this is what we have said. We have said that you should be able, when you're using this trait, pizza trait, you should be able to use this property, right? You should be able to get something out, right? That's what you're saying, basically. That's your contract. That's your promise. You're saying, we want to have this max number of toppings if you're using this extends pizza trait, right? So how you get it? You have a wide variety of choice how you want to implement this functionality. You know, fixed, right, variable, or maybe you want to pass it along. So this is completely fine, right? So what's the difference between this? So this is fixed, right? This is not, I mean, this is going to be, it's going to be fixed, but you can specify it. So that's a big difference. Difference between the custom on a medium pizza is that custom pizza can receive a specific number, not just 7. So that's the main difference. So let's try one more. So I don't even have to do anything here. I can just basically, right? I don't have to type anything, right? So my trait says I need to have maximum number of toppings. I say, okay, it's going to be a constant, but I'm going to pass as parameter. Well, there's one more way of doing also custom, right? Also custom pizza, right? And I'm going to do, so my toppings, right? My topping count, right? My topping num count, right? Again, int, and extends pizza trait, right? So it's still red, right? So how do I do it? I can do basically, you know, I can do val or var. I can do, let's say val. Doesn't matter. Let's do val. My topping. I'll do my maximum toppings, right? Maximum toppings. Toppings equals, of course, my topping count, right? So longer way of doing the same as custom pizza, right? So we get the same result, right? This is of course much, I would use this in real life, right? So again, that's why, so this is the tricky part about these unparameterized, you don't use val or var, remember these are just uses only parameters, they don't have these access methods, right? That's why it didn't work, right? So you have to have it right? When you create this kind of field, right? So basically these become fields inside. Basically you have access, you have getters, setters, well, getters for val, setters for variables as well, right? So let's try it now. So we have how many pizzas? We have 1, 2, 3, 4, 5 pizzas. Let's make them, right? So I'll call them in the or traits section, right? So inside we have our pizzas, right? So I hope I'm still recording this. I am recording, that's great. So we have one single trait, and we created 5 different classes utilizing this trait, right? Okay, on which one? Only one of, well, these 2 have the ability to receive the custom count. The other ones basically are fixed, right? No choice, right? Except of course medium pizza will be able to change this, right? Because this is a variable, right? So out of this simple definition, we gain a wide variety of implementation choices, right? So let's run it. I'll put it here, and after dogs, right, we're gonna order some pizza, right? So let's have some pizza fun. Let's order lots of pizza. Order lots of pizza. After doggies, right? We have kitties. We have a big family to feed, right? So we'll have a small pizza, right? And of course it is a new small, right? There we go. And do you have anything? No. And of course I can do print line small pizza dot max number toppings, obviously, right? And I can't do much else, right? It's a fixed field. It's a limited class so far, right? No other method. Okay, medium pizza, right? Equals new medium pizza. Notice again, so of course these names are arbitrary. I just picked one because it matches the class name, but of course this is the object, that's a class, right? So again I can do medium pizza, print line medium pizza, and maximum toppings. But of course we have, here's the difference, it's a var, right? We saw it here, right? We made it a var, so that must mean I can decide to change my mind about my pizza, and maybe maximum toppings, right? Now toppings, come on, my pizza, I can't type again. Maximum toppings on, come on, medium pizza on dot maximum toppings. I can do plus equal, maybe I'll add 12, right? This works. Same as, right? Same as, right? Since I'm lazy, equals I'll put it basically, right? Remember this is shorter way, right? So you can see Control Z, no, come on, and I'll do this is equals this plus say 5, right? So you can see, right, this is a shorter way, right? We can say so above plus 5 can be written in a shorter way. Okay, so now we'll have huge number of toppings, right? So let's see how this works, right? Same as plus 5 line, right? So this is a shorter way of writing this long line. Okay, let's see. So we have the fixed pizza, the small pizza, you don't get the choice, medium pizza, we can pile on the toppings. Let's run it and see if that really is the case. Yes, so we started out with 7 toppings. Let's check this out. So 4 was a medium small pizza, 7 for the starting. Why? Because we said var is 7, right? Okay, we had to implement something. We started with 7. Okay, so then we added 5. We have 12, and we added 12 more, and we have 24. And of course we could keep mutating because we said it's a var. Okay, great. So the large pizza is not going to be very interesting, but I'll add nonetheless. I will add it. Equals new large pizza, right? Basically it's same, so just fixed print line, right? Large pizza and dot maximum. It's actually a method. Notice the only difference, it's a method, right? Only difference, right? This not val but method, but the result is the same fixed result, right? Is same fixed result, right? So let's do that one. Yes, so 23, why 23? Because we said so. We said so in here, right? 23 as a function. Again, so this will be an option to do it. Again, so and let's try our custom pizzas. We have two more pizzas. Let's do a custom pizzas, and these are values, but we can in fact use them as a setter. So val custom pizza, nice, thank you. Suggestion, nice suggestion. New custom pizza, and I need to put a value. So I want say maybe 17, right? And now of course I can print, but I can't change, right? Right, max number of toppings, and of course I'll have 17 toppings, right? So you see the difference, right? Here I don't have any parameters, I have no choice. Here I do have a choice. So let's do, so this would be same. I could do a var here, of course, right? I could do var, right? Yeah. So, right, I'll do var, you know, could use var or val depending if you want to change value. So now I can, so this would be, I can have a pizza, I can set the value, right, using this parameter, right, here. But after that, I have a variable field, and I can also mutate the value. So I have everything here. So this super custom pizza, basically, right? I'll save it, right, and let's run that one. So super custom pizza, right, custom pizza equals new also custom pizza, right? And I'll do maybe, I'll start with maybe 10, right? But I can now print line super custom pizza, right? I'll have maximum toppings, of course, still the same thing, because they all of these pizza classes, these blueprints, they use the same trait, so they implement the same functionality again. So it is a way of, again, organizing your code and in subcategories. So and now I can mutate, right? I can mutate super custom pizza. I can do plus, oh sorry, max number toppings. It's mutable, so plus equal. I'll do 77, right? It's all legal. I'll have 87 max number of toppings. So let's see, that really is the case, and I think you will find that this is really the case, right? So no surprises, right? I can mutate since I set the field as var, right? Again, so let me run this, right? 87. Okay, so again, these are parameters, right? Inside these are fields, right? So if I'm using it like this as with val, right, or var, right, again, then inside I have these setters or getter method, so then it actually becomes, you can use it as a field. Here I actually say it's a field, meaning, but I am gonna take the value from incoming as a parameter. So this part here, this one is not gonna be available afterwards, right? You can't access it from outside. So what's the difference? So this is not accessible from outside. This is not accessible from outside. This is, right? Val and var are accessible by users, by those who create the object, right? They can use it here, like I was doing here. But I don't get access to this, my topping count. You see, this is not available, right? This part here is not available, right? So that's key part here, right? Again, so print line, my super custom pizza, it's not suppress warnings. I don't want suppress warnings, right? Super custom pizza, right? Maximum toppings I can, but I don't have my topping count. You see, my topping count, it's gonna be red. You see, red. No access to parameters without var or val, right? So that is, yeah, no public access, right? It becomes, again, so again in Scala, of course, so this complexity is because we have many ways of attacking the problem, basically, of solving a problem. Again, very flexible, right? But and again, the most part, you don't have to worry too much about most of these things. You probably won't have to do much extending yourself, but at least in the beginning, right? But it provides you, at least you know what's going on underneath, because this interface, this trait as an interface is quite nice, right? It's using, you know, you can build up large systems of, you solve one small problem, right? Or you define, at least you define one small problem, and then you can use these classes you build, can extend this problem solution at least, or at least problem definition, and then actually provide the actual solution, right? So very, again, some people really like this type of thinking, again, and you can, of course, you can go overboard. Like, you can build these castles in the sand or in space, right? You can call these people architecture astronauts, but again, there's always a balance, right? Maybe no traits whatsoever, probably going to be hard to make bigger programs. Small, again, too many traits, maybe it's going to get too complicated, right? Or too abstract, right? But again, I think in small doses, traits are quite excellent, right? Again, so I hope you got a good idea how traits work, and that will again provide them for further information on how to build larger programs. Thank you all for this section, and we will continue.